After 5 months of hard work, the wall running mechanic is finally ready. A Spider-Man inspired wall running movement system. You'll be able to run up walls, run down walls, wink wink, switch walls, and more. You can choose what kind of walls to be able to run on, and if you want to use tags. Unfortunately, running 90 degrees isn't going to be possible. Psych! Of course you can do that too. The best part is that you can fully customize how you want the wall run to work with settings we will create using a wall run component. There's a lot of stuff to do, and it's gonna get confusing here and there, but it's totally worth it. You can also get this project on my Patreon and just copy, paste everything and be done in less than 5 minutes, just so you know. So the way the mechanic works is, there's a line trace going from your actor forward. If it hits a wall that you allow to be traced, you will change into wall running mode. From here, there's a second line trace going straight down to keep track of what wall you're on. And if you're still wall running, gravity will even pull you towards the wall. So if you want, you can jump as well. Start off by opening up your character class, and in the character settings, set gravity to be at least 1.75, max step height to 50, and walkable floor angle to 50. There's a macro we're going to need to make in order to avoid wasting time. Begin by creating a macro library for the actor component class. Add the following inputs. For this float, it's important that you set the delay to be as small as Unreal possibly allows you to. Just keep adding zeros until it resets, or add 5 zeros and 1. Add some outputs as well. Basically, we're gonna create a macro that will keep looping until time's up. Think about it like a temporary tick. Make sure it's a retriggerable delay and normal delay. Once you're done, copy the macro and create another macro library for either the actor class or character. Paste. How you choose to apply when wall running should be possible is entirely up to you, but it must run on tick. Create a wall running variable. Create an actor component. I found it kind of complicated to add a component from here, so instead I like to just drag it in manually. We'll make the code in the component to avoid making a big mess inside the character class, but you can also do it in there directly if you like. Create a wall running boolean here as well. I like to add a C for component in front of the name to avoid confusion. Add a line trace. How you choose to trace for walls is up to you, but I recommend using profile for more flexibility. That way you can choose a profile you're not using in your game, and if you set it to block by default, it will be traced. If you set it to overlap, it will ignore it. You can also use tags to avoid being collision specific altogether. We'll be tracing from the actor and forward. But since we'll be rotating the mesh and not the actor on the wall, make sure to use the mesh's forward vector. To do that, you will need to get the mesh's right vector. That's because by default, the mesh is rotated at 270 degrees. Depending on your settings, you may have to use another vector. You can play around with the distance, but I like 95. Promote the impact point and impact normal to variables. You don't have to do this, but it's helpful to avoid spaghetti, and I'm assuming you're not hungry. I'll just line them up like this instead to make it look cleaner. To avoid running when there's limited space, we need to do a sphere trace as well. What trace you use here is not very important as long as it can detect objects with collision. Multiply the normal by 50 and add it with impact point. This will give us the impact point but more forward or higher depending on the angle we look at it from. Exact same formula for end, but increase the amount to 70. Back in our character class, call the wall running event we just made. Make sure it's on. This works, but it's not enough. Unfortunately, we can't just increase the radius because that makes it wider as well. A box trace doesn't align properly in the world, so instead we'll have to add another sphere trace after. I'll also change the trace color of the main trace just to keep track of stuff. Create another variable and connect true to a branch. On false, we'll repeat the sphere trace with slightly different values. You will need to account for the size of your character, but this should work fine in most cases. Connect the false to the same type of branch. Let's check the angle of the wall we're trying to run on. You can sort of choose the value yourself, but it may look weird, and the wall run isn't really meant to be used at angles like this. So proceed at your own risk. Create another event and move it aside for the time being. Here we're going to check the opposite angle. Create a variable and create a new category called settings. This is useful and will make things easier to tweak from the character. I also like to make things visually more appealing, so I found a gear emoji and I want to use that for the settings variables. Create another variable called WallRunning. I'll move the start trace code a bit up to know which trace this is. From hit actor, check if the actor has tag. What tag you want to use is up to you. Create another variable that checks whether we run 90 degrees on the outside. Since there's a lot of ways to switch walls, it's hard to come up with a good name for each type, but basically, wall corner means running 90 degrees or more on the outside. Switching edge will refer to switching walls less than that, both on the inside and outside. Switching wall will refer to the first line trace hitting new walls. Actually, never mind. Add a do once instead. Connect the falls to the wall running branch as well. Add a dot product. I have a separate video explaining how dot products work, but basically we're going to check the angle we face towards the wall in order not to start wall running before we face it enough. You can play around with this value, but I like 0.7 or 0.75. Create a new float variable and call it zNormal. And zNormal too. Spoiler alert, we'll be making a lot of variables. What this formula does is it gives us the direction of the wall. So whatever angle the wall is rotated to, we can match it. These reset events will be used when we end the wall run. Here, check if we're falling and add a sequence on both outputs. This is to adjust for if we're wall running while falling or not. Connect to a gate and open it. Here, we're going to check if our velocity is greater or less than 10. Use an absolute to avoid checking less manually. Create another variable called moving. This will check if we're pressing our movement input or not. Add another close event. I remember the order differently, so that's why it's 5 here and not 2. Set the mesh's relative rotation using an R-interp. Set speed to 5. In order for the mesh to orient towards movement, we will need to create a formula that will turn our velocity into world rotation. That will also take the world rotation and convert it into relative rotation. Not confusing at all. From here, get an Aton 2, subtract by 90 to account for the mesh being rotated. Create another event and move it aside. I like to print what happens just in case we have any issues later on. It'll be easier to find. This wall counter variable really only has one job, and that is to separate our first wall mount from other walls we may trace later on. This is the switch wall I mentioned earlier. Create another event in our unused event section. So, since the move component to node doesn't work well outside of a character class, we will need to create the event in the character itself and just call it from the component. For the location, we want to do the same thing we did earlier by adding to the wall height. I found 92.3 to be the perfect value for this. If it's not perfect, you'll deal with this. But again, you may need to adjust based on your scale. Sometimes I use question marks, sometimes not. I still can't decide what's better, so sorry about that. But in this case, it's because there's gonna be another variable with the same name later. Also create a stored z variable. This is to get a difference between current and previous value. Up here, we're going to add code to incline the mesh. Create a vary that checks whether you want it to be inclined or not. Call the gate loop we made earlier. and set speed to 13. Here we'll be doing the line trace that goes down on the wall. This is going to be the code that ends the wall run if the line trace doesn't hit anything, among other conditions. Create another setting variable. With this checked, when you jump, you will jump off the wall. Unchecked will allow you to jump without disengaging. Create 3 new varies that will be used to check whether we're hitting something with the line traces that will check for gaps later on. Also, add switching wall. Create another event in our event bunker. We'll need to set the line trace to be a little bit behind the actor to be more accurate, and then trace downwards. Minus 150 is a good value. Create another normal variable. We'll also need to know whether our character has jumped and landed or not. Go back to the character class and set it like this. If you're using 5.6, you can repeat the same steps for the jump code, like this. Also make sure it's true by default. So we'll be doing the same line trace, but with more length, if jumping is allowed on the wall. Just increase the distance to -400, or should I say decrease. Add a sequence and move it far away. We'll use this variable to get the wall rotation of the wall we're currently standing on. Check angle again. Do the tag thing again. Create another vector for the normal. Technically, this is the second normal variable, so let me just... Create another variable called rotating. Here we'll be setting our character's rotation towards the wall's rotation. Set Z to Z normal and Y to 90. Promote the speed to be a variable, set it to 7. Here we want to check if our character's rotation is close to the Z normal. That's because very often they're just decimals apart. I was curious to see how Spiderman dealt with edge switching, and what they do is force you to move a little bit. So that's sort of what we'll be doing too. But as a bonus, you can also not do this and move like this by turning off the variable. Beat that, Insomniac devs. This is however limited since you won't be able to take advantage of camera movement, and movement across walls will be slower. Down here, we want to set the gravity direction. This was way more complicated when I was first trying to figure this out. I had a big system where if the wall rotation was at 70, for example, set gravity to be 1 on X and 1 on Y, and it was just a big mess. Needless to say, using the actor's up vector was a great solution. Create two normal variables, idle 1 and 2. These will be used for camera movement later on. Set delay to 0.003. This branch will check for a difference between the variables, and if there's a difference, we will rotate towards the new wall and move for a couple of seconds towards the new wall. I'll add a branch that we will skip for now just as a reminder. Add two more booleans in the settings. I'll explain what these are for later, but trust me, they're very useful. Get the move 2 seconds event from the events. Create another one to reset the do once. Call that event as you call the move 2 seconds. Create an event called start track here. Again, print for testing purposes. Create another dot product, but this time we'll be checking whether our character is moving right or left. This code is optional, or this branch, but in case you ever run at a high speed, you will need to slow it down for the character in order to prevent bugs. So basically it accounts for high speed running. Set max acceleration to something high like 30,000. It shouldn't really matter as long as it's something high. Add movement on the actor's right vector. Do the exact same thing for the left side, but flip the scale value. You could also negate the vector if you wanted to. Reset the acceleration to its default value. And turn off the boolean. Copy the dot product and check whether we're moving right or left here as well. Create another setting to choose whether to check for gaps or not. We're actually going to make 2 line traces in each direction. we're going to trace slightly to the right of the actor. Do the tag thing again. Rod X thing again. On the left side, we'll just flip the direction. Add the same line trace again and increase the down direction to -300 and right direction to 65. Here we're going to add a system that checks the height of a detected wall. So if the wall is higher than the character, don't allow it. On the left trace, you want to reset the right trace and vice versa. We also got to change the gap wall right to left. Also connect this on both. Alright, that seems good. Let's move on to the 90-degree trace. In case you don't want to include this trace in your game, you can turn it off with this vary. Copy the velocity check we made earlier. Direction check again. I'll set this line trace to be persistent for testing purposes. So here, we're going to trace a little bit differently. We'll have to trace to the right of the actor and further down. From here, we will trace right into the wall. In order to pull off the 90, the trace needs to hit something. We also need to do a box trace to avoid doing the 90 run if there's something in the way. Set the orientation to match the character's Z rotation, otherwise this will happen. Create a vector variable for the box size. check whether the wall angle is greater or less than your desired value. Same thing here. If we come at a high speed, we need to slow down. To get the 90 run right, we need to slow down the rotation speed for a small duration. We'll also add movement here like we did earlier. Set max acceleration to something high. Value shouldn't really matter. So now we're going to have to do it all over again for the left side. Just kidding. Copy and paste. Now let's make the end WallRun event. Down here, we're going to check whether we're actually exiting the wall run sideways or from the top. This isn't necessarily required, but otherwise you will end up with a little bit of jerky movement when going off sideways. Do the direction check again. Notice that we're tracing to the left on the right side. Create a new boolean for falling off sideways. Add two events in the event collection. From here, we're basically just going to reset 99% of the variables. Create a float variable we're going to use later. And an integer. And another. 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 By the way, we're gonna have to switch these brand conditions with the WallRun ability instead. They serve the same purpose, so to speak, but the wall running variable gets turned off a little bit later. Go to all the code we have when applying movement and change it. In total, it should be in 6 places. Here, we're going to need to check which way the mesh is facing, so that if we jump off the wall backwards, we can rotate the mesh and actor properly. Create another event in the character and call it. This will check whether we want to run up the wall or just jump up. Again, jump value is up to you. This event is going to reset all the gates and do ones we made earlier. It's hard to find variables in this big pile. Set orient rotation to movement back on. Create a gravity speed float and set the default value to 8. We're going to set this value differently depending on how we exit the wall run to get the smoothest transition possible. Here it's important that you set the max walk speed to 600 regardless of what your current speed is, otherwise it might fail. Create a new vary called climbing wall and set it to true. Set gravity by using vinterp to constant. Normal gravity direction is -1 on Z. Connect the gravity speed vary to the speed. We'll also need to rotate the mesh, but don't confuse the incline mesh rotation with the mesh's Z rotation. Set the Z back to the default value. Copy the jumping branch. Here we're going to set the values just in case the interping doesn't finish in time. Here you can set the max walk speed back to your default. Add movement to the actor's forward vector. Call all the close and reset events. This one's very simple, just add a move component too and set the settings like me. By the way, change the move to new wall code like this. Alright, let's try it out. It seems I made some mistakes, so let's fix it. I forgot to connect the false here. So now we can get on the wall, but the line traces seem to be working in the opposite direction. So yeah, it seems I used the wrong check for the trace. I was supposed to check greater instead of less. That's better. You'll notice that we can't move up or down. That's because by default, Unreal doesn't account for movement on the Z-axis. Luckily, it's a pretty easy fix. Open up your animation blueprint. I'm using the NMBP from 5.5, but it has changed a bit since then. The important thing is to run this code on tick in the blueprint. Check if the WallRun component is valid, and if it is, check if we're wall running. I'll just set up the mesh incline variable while we're at it. In 5.6, it's pretty much the same thing. But we have to set the direction as well. I personally don't care much for the strafe, but if you want it, you'll have to skip it when wall running. Also make sure not to use control rig for wall running to work smoothly. Alright, let's get started on the movement. Create an event and add X and Y float values. Wall movement is a difficult subject because there's so many different ways you can want to move. However, in this tutorial we're focusing on Spiderman-like movement. This means that we want to move based on what direction we're looking. But there's a problem. If we look here, we know we want to go forward. If we look up, we know we want to go forward, but what if we look straight into the wall? How do we convert that forward into up? Go back to the character and find your movement code. In 5.6, find your movement and add the rest of the code here. Set moving to false on completed. Here we need to check the rotation relative to the actor's rotation. So to do that, we will need to subtract control with actor's rotation. Basically, it tells us where the camera is facing. We'll need to change movement direction based on what this value is. You can play around with these values if you feel like it should be different, but for me this worked the best. We'll also need to account for the camera being inverted. So let's make a vary for that. Get the second down normal, and this time do a cross product. Set action X to be the scale value. I'm going to add a tick just to show you, but you don't have to do this. Create another variable for disabled movement. Here you can see the value changes based on where we're looking relative to the actor's rotation. I'll turn this off for now. So after some debugging, I found that we haven't connected this false either. It's easy to make mistakes when there's so much code to make. So now we can move if the value is in between 60. Things might get a bit confusing here, so bear with me. We're going to check the Y value here. The Y value is a bit hard to deal with because there are certain angles where you don't know what direction to move. Copy the cross product and this time flip the direction. Oops, that's wrong. Here we'll only move on the z-axis. Now you'll see that we move differently based on where we look. That was movement on the x-axis. Now let's set up the y. Y movement is much quicker to set up. The challenge here is to deal with looking forward, since we can't move into the wall and need to make this move up. Here we'll be using and instead of or. Here we're going to create a formula that removes that angle I mentioned. That works splendid. Here we'll add some conditions to decide what kind of movement to do. Create another camera variable. This one will be used to check whether well, I guess the name says it all. If you also want to account for using a controller, create a using controller boolean. So what is this track thing I mentioned earlier and the variables we made, and this movement feature we're about to set up? I initially thought Spiderman had it, and I thought, that was so cool. Although I realized later that Spiderman doesn't actually have this feature, but it gave me the idea and I thought this is a must. Basically what this does is it makes sure your movement continues in the same direction until you stop or change direction. It starts when we change walls. So this is by default how movement works without the feature. Now the feature is turned on. This is very useful for navigation and control of the movement, but as anything else in the component, you can always choose to turn it off. I will also set a temporary version of this feature because without it, we'll be dealing with this kind of issue. Here we want to check if our input aligns with the direction flows we made earlier. Another vary that will be set up later. Here we want to add movement to the mesh's forward direction. When making this the first time, I kept the scale at 1, but I want to see if feeding it the action value instead will work better. Here, we'll need to check whether rotation, direction, and input is aligned. Now we'll have to do the same thing for when the camera is inverted. You want to keep the dot product positive, but flip the two other checks. Now let's set up the track feature. We're getting closer to the finish now. We'll be checking the same way we checked movement earlier. Here we don't have to be super accurate with the values. The idea is just to choose whether X input is correct or Y input based on where we look. Things are about to get confusing, as if they weren't confusing enough before. We set the direction based on where we're looking and what we're pressing. That's essentially what this whole thing is. In this branch, we'll be checking for controller input since the joystick can be X and Y simultaneously, and the action value is much greater than 1, compared to a keyboard. Also make sure using controller is off by default. I'll also turn off temporary track for now. I was wrong about using the action variables after all, so let's just remove them. I also didn't connect the false. It's working, but there's a few bugs. I forgot to add a minus here. Also reset from false. Same thing here. Here I set the action instead of direction. What's going on with me? So many mistakes. We also want to stop the tracking if the character is not moving and velocity is 0. You can also just check if the character is not moving if you want to cancel quicker. Now let's set up the mesh incline. Let's make the code first, and then I'll explain how it works later. You might get stuck at certain angles, so to fix that, we'll check if the actor is not moving but trying to move, and if so, switch edge. A location variable will be used to check if the actor is stuck in the same location. The 90 run is failing, so let's fix that. Oh, I'm using the wrong check here too. I also forgot to set the box size. You may have to choose a bigger scale depending on your character and if you're going to use the incline. This one's supposed to connect on false. There we go. Still not done though. We'll fix the rest of the bugs later, but first, let's add the jumping code. We'll end the wall run if we don't allow jumping and call this code from the character if we're wall running. I want to jump a little bit away from the wall as well. But again, how you want the jump to work is up to you. Up vector gives us the direction behind us, so we'll jump a bit out. The delay here will choose how quick or slow you will disengage from the wall when jumping is allowed. I also forgot to set the mesh rotation back to 270. Finally, let's get to the camera movement. Last big thing we have to do. Call the camera move event on tick in the sequence. This is the other move camera variable. It's used for you to determine whether you want to allow camera movement or not. Open on true. Close on false. Close again when entering the gate. Remember how I said things would get confusing? Well, this is the final boss. Get the rod X and normal idle too. Add by 180. modulo by 360, add by 360, modulo again by 360, and subtract by 180. This big thing is going to give us the difference between our previous wall and current wall. It will also account for rotation issues. That way we'll know exactly how much to rotate the camera and whether to rotate right or left based on whether the value is positive or negative. We don't want the camera to rotate within a very small threshold. I found 19 to be a good value, but again, you can try and see for yourself what you like. Create a new float and make sure to reset it in the end. I'll print this value as well for testing purposes. Copy the big thing when switching wall. When switching wall, we want to do it like this. This time, check if it's less first and greater second. If the camera rotation is not finished, we need to add the leftover value to the rotation or subtract based on direction. That's what the camera counter variables are for. Add the control rotation with the rotate camera too. Then add it with the leftover and set the var. Down here, don't add, but subtract with leftover. Make sure to subtract the leftover second and not first. When to close isn't too important here since we're going to close when it's finished. Just make sure the value is big enough to last. Otherwise, you may switch walls a couple of times in a row and the camera will stop. This shouldn't be a problem if your camera move speed is fast though. Make sure you use F-interp2 here and not R-interp2. That's because the R-interp2 goes from minus 180 to positive 180, and that sort of ruins the math we're doing here. I like 180 for the speed. Now the camera leftover will be set based on how much rotation we have left. Here you want to subtract first and add second. Also notice that I set the values opposite now. This is to stop camera movement in case we manually take over the camera. In 5.6, there's two look events. If you want to use a controller in your game as well, make sure to use both. Here you can choose whether to allow camera movement if the camera is rotating, or if you want to stop it. Leave true empty if you don't want to allow movement. Alright, let's fix some bugs. Go back to the sphere trace and call the rotate mesh event. I also used the wrong check on the sideways trace as well. That's what happens when you copy and paste a mistake. This is also wrong. I have filmed this wall running video 5 times and every time I've gotten something wrong. Also, on move for 2 seconds, add this check. Let's copy this code here. Go to the branch we skipped earlier. We're doing the same thing here like we did to prevent the camera from moving within a small threshold. We also want to prevent the character from moving. You can reduce the value here a little bit if you want. I'll set it to 10. Now let's set up the wall down event. This is when we choose to walk down from the wall. Since using the default mesh's line trace can cause some weird movement because we're tracing from the mesh, we'll do a separate trace from the actor's forward vector here. Copy the toWall event and call it. Do the thing we did earlier to add height to the impact point. Here we need to disable movement while the character is transitioning, otherwise it looks weird. Since the end wall run won't be called from here, we need to reset things again manually. Copy all the variables being reset and create an event. Now it's time to deal with getting off when the mesh looks backwards. We'll need to do things a little differently depending on whether we're jumping or walking off backwards. We're going to need to move component and interpolate gravity. To get the right rotation, subtract the mesh relative by 90. Also set velocity to 0 or stop movement. Here we set the delay to 0.1. Forgot to reset here. Ah, it was supposed to be world rotation, my bad. I also forgot that wall running isn't reset in the variables. If we want to incline the mesh, you'll see it won't work. There is still one more thing to do in the NMBP before it'll work. Add a modify bone node. And set the rotation mode to add to existing. Choose hips as the bone. It seems I used the wrong dot product vector here. Like I said, easy to mess up when you've spent 5 months trying to figure it out. There we go. So there seems to be a mistake when switching cameras while doing the 90 run. Remember when I said,
set max acceleration to something high. Value shouldn't really matter.
Well, it turns out that it does actually matter. That's what's causing the camera to glitch. Set it to something like 8000. I also made a mistake here. If we try to climb the wall at a too steep angle, this might happen. We can just avoid removing velocity on Z. This will be better, but not perfect. We'll need to jump off the wall instead if we're too far off. .25 or .3 is a good value. Also add a launch character. Set the switch camera gate to start open. Let's set up the stay on track feature for controller as well. This is actually very simple. All we need to do is to check whether direction and input aligns like before, but this time instead of checking the exact value, we want to check in range. We tend to flicker the joystick a little bit, and it shouldn't mess up the whole track feature. The bigger value you choose, the more you're allowed to flicker the stick before breaking the track. Notice how much further I can move the stick while staying on track. I'm not sure why I set up the angle like this earlier, but we can actually avoid checking here altogether since we're already checking. First, let me demonstrate what each angle looks like. You'll notice it starts looking weird from here. Anything above this is at your own risk, since the WallRun isn't really intended for these kind of angles. This is the same thing but on the opposite spectrum. You'll already notice issues with mounting the wall. This angle is also above 0.4, which shouldn't be allowed. Let's also add the minus. I used OR in most of this tutorial because it's easier to visualize what's going on, but we can also just use an absolute to save some time. Here we have a problem because we can mount the wall but not stay on it. That's because I originally set it to allow these kind of angles because of this. Look at what happens if we don't do anything here. To allow this and prevent mounting the wall at this kind of angle, we just need to connect it a little differently. We don't actually need to do anything on true. The last thing we need to do is to add a small bit of code to allow us to run on curved angles. Although the WallRun should be able to handle most angles, it's intended to be used on walls with plenty of space and good angles. Go beyond at your own risk. Here are some examples of bad angles. You definitely want to avoid this at all costs, since you may confuse the line traces. As you can see, the WallRun can handle this to some extent, but believe me when I say it wasn't the case at first. The 90 WallRun diameter is maximum 0.4, so make sure that any wall you try to run 90 degrees on is at least 0.4 or more in thickness. I would recommend at least 0.5. Let me summarize what all the variables are for. The tag variable allows you to limit wall selection to walls that contain a tag of your choice. Jump and's WallRun will either disengage you from the wall or allow you to jump while wall running. Jump on finish determines whether you want to run up a wall or jump up. The incline will give you an angle and the value will choose how much. The mesh's X and Y rotation will be affected to add some incline. We'll use the incline value to choose how much. Going up and to the side works fine like this, but going downward can look a bit weird. So by adding this code, you can choose what angle to have when going down. Move on edge will either force you to move when crossing edges, or allow you to move on the edge directly. The track movement will make you continue moving in the same direction you're currently moving in when switching walls or edges. The temporary version is more of a bug fix, even if you don't want the main on-track feature. I'd recommend taking use of this. Cross gaps allows you to cross gaps. Who would have guessed? You can cross small gaps without this enabled, but it allows for a little bit more space between the edges. With this, either you allow 90 runs on the outside, or you don't. To specify, this is on the outside, this is on the inside. Box size is the collision that checks whether there's something in the way of our 90 run. Turn this on if you're using a controller to adjust for the move on track feature. Either you want the camera to move, or you don't. Finally, there's the speed you want the camera to move at. The WallRun ability variables allow you to control when wall running is allowed or not. It's entirely up to you how you control the use of these variables and when you allow wall running to be true or not.